Imagine an object that was already ancient before our sun was even born, long before the earth had cooled, long before the first atoms of our oceans condensed. This object was already drifting between the stars, silent, cold, and patient. Today, that very same traveler has entered our solar system. Astronomers know it as 3I Atlas, the third confirmed interstellar visitor in human history. But a team in Spain has offered a different name, a name that I think truly captures its profound significance. A cosmic time capsule? Think about what that phrase truly means. We as a species are defined by our obsession with the past. We dig through desert sands to find pottery shards. We carefully brush dust from the bones of dinosaurs. We drill into the ice of Antarctica to analyze ancient air bubbles, all in a relentless quest to understand where we came from. We do this because we instinctively know that to understand our present, we must first understand our origin. The objects in our own solar system are like this. The comets from the distant Oort cloud, the asteroids in the belt between Mars and Jupiter. These are the leftover scraps from the formation of our sun 4.5 billion years ago. They are our local time capsules, a 3I Atlas. This is something else entirely. This is not a piece of our history. It's a piece of galactic history. It's a time capsule from another solar system, one that may have formed, lived, died long before our own. It is a physical fragment of the universe from before our time, and it has just been delivered to our doorstep. We are right now living through the precise moment that a message in a bottle, floating in the cosmic ocean for perhaps 1 billion years, has washed ashore. And this generation, are the first in human history to be here to read it. This object is only the third of its kind we've ever confirmed. The first one on Almubba in 2017 was a shock to the system. It was a bizarre, cigar-shaped tumbling object that accelerated away from the sun without any visible gas or tail. It defied every natural explanation we had. The second 2A Borisov in 2019 was almost a disappointment simply because it was so normal. It looked and acted just like one of our own comets, which, while fascinating, suggested that other solar systems might just be built like ours. But 3I Atlas is the one that truly changes the game. It's not inert anomalous like Oumuamua, and it's not normal like Borisov. It's something new. It's category 3, the primordial relic. And it's teaching us that our most basic assumptions about the universe are fundamentally incomplete. Oumuamua's anomaly was its motion. It was pushed by a force other than the sun's gravity, yet had no visible jets. This led Harvard's Avi Loeb to suggest it was an artificial solar sail. The scientific community scrambled to find a natural explanation. First, they proposed it was a hydrogen iceberg, a giant chunk of solid hydrogen. This was a clever idea. Hydrogen is transparent, and as it sublimated, it would provide the invisible thrust. But that theory quickly collapsed. A hydrogen iceberg is so fragile it would have evaporated on its long journey through interstellar space. It wouldn't have survived to reach us. A second theory, the nitrogen iceberg, a chip off a Pluto-like exoplanet, was proposed. But recent studies have shown that for this to be true, the universe would have to be filled with an impossibly large number of these nitrogen ice world fragments. The numbers just don't add up. Oumuamua remains a profound unsolved mystery. Now 3I Atlas arrives, and its mystery isn't just its motion, it's chemistry. To understand why this object is so important, we have to talk about age. Our sun is what we call a populationized star. In simple terms, it's a metal-rich star. In astronomy, metal means anything heavier than hydrogen and helium. The carbon in our DNA, the oxygen we breathe, the iron in our blood, these are all metals. They weren't created in the Big Bang. They were forged inside the hearts of much, much older stars. Population too. Stars that lived, died, and exploded, seeding the galaxy with these heavy elements. Our solar system is built from the ashes of these dead stars. We are quite literally the children of a stellar graveyard. But what if 3A Atlas isn't? What if it's older than our sun? What if it's a population 2 fecundation 2 comet formed in a metal core environment? If that's true, it's not just a time capsule from another place. It's a time capsule from another epoch of the universe. It would be a pristine physical sample of the early cosmos, from before stars like our sun even existed. And right now it is flying past our telescopes, and it is activating. It's waking up. This is where the mystery begins. The Atlas Survey System first spotted it in December 2024. By October 2025, it had reached a distance of 3.2 astronomical units. Oh, from the sun, that's more than 3 times farther than Earth, well beyond the orbit of Mars. At this distance, the solar radiation is incredibly weak. The temperature is a staggering minus 150 degrees Celsius. In this environment, water, the engine of all comets we know, is frozen solid. It should be inert. It should be a dead frozen rock. But it wasn't. The Neil Degrelle Swift Observatory, an ultraviolet telescope, was pointed at it. Scientists expected to see nothing, or maybe a faint whisper of carbon monoxide gas. Instead, they saw the unmistakable, powerful signature of water. Not just a little water. The data showed 3I Atlas was spewing out 40 kilograms of water vapor every single second. That is the output of a high-pressure fire hose running at full blast. How is this possible? How can a rock be blasting geysers of water in a place so cold that water should be as hard as granite? This is our first clue. This isn't normal ice. Our comets are mostly made of water ice. Damn. But this object's behavior suggests it might be made of something called amorphous ice. This is a disorganized, messy form of ice where other, more volatile gases, like carbon dioxide and carbon monoxide, get trapped inside the ice structure. As the comet gets even a tiny bit of warmth, these trapped gases begin to escape, and they're so violent that they blast the much heavier, frozen water ice crystals out with them, creating the water signature we see. This isn't sublimation. It's a series of mini explosions. This isn't just a theory either. We have a parallel for this kind of impossible activity right here in our own solar system. It's called Comet-29P Schwarzmann-Hagen. This comet orbits in the freezing cold between Jupiter and Saturn, where it should be completely dormant. And yet, 29P is one of the most volcanically active objects we know. It erupts in massive, violent, and completely unpredictable outbursts, sometimes increasing its brightness by 100-fold in just a few hours. We still don't fully understand what's driving it. It proves that even in our own backyard, comets can have complex internal engines that defy our simple models. 3I Atlas is like 29P, but from another star, it's an impossible comet that's showing us its internal engine for the first time. But the water was just the appetizer. The main course came from the James Webb Space Telescope, JWST. When Webb used its powerful infrared spectrographs to analyze the chemistry of that gas, it found the smoking gun. In our solar system, comets typically have a carbon dioxide to water ratio of about 1:1, maybe 2:1 at most. Then 3I Atlas has a ratio of 8:1. 8 parts carbon dioxide for every 1 part water. This is off the charts. It is definitive, mathematical proof that this object was not formed in our solar system. It must have been born in a vastly different environment, a place far colder than our own frost line, a place much richer in carbon. We are, for the first time, looking at the chemical fingerprint of a truly alien birthplace. As astronomers watched the comet's coma, they detected the brilliant green glow of swan bands. This is the signature of diatomic carbon, or CO2 carbon atoms bonded together. This isn't just a simple chemical. This is the fundamental building block of all complex organic chemistry. It's the starting point for the long-chain hydrocarbons, the amino acids, the very molecules that on our planet assemble themselves into life. This is where the time capsule metaphor becomes literal. We have found these building blocks before in a time capsule from our solar system. In 1969, a meteorite fell in Murchison, Australia. It was a pristine piece of the early solar system, 4.6 billion years old. When we cut it open, we found it was packed with over 100 different amino acid proteins, the molecules of life. The Murchison meteorite was proof that the ingredients for life on Earth were delivered from space, riding on comets and asteroids. And then there's the other famous time capsule, AL Heidi 4001, a meteorite from Mars, found in Antarctica. In 1996, NASA scientists announced they had found what looked like fossilized nanobacteria inside it. This created a massive global controversy. While the scientific community is still divided today, with many believing the structures are just non-living mineral formations, the debate itself proves something crucial. We are already seriously looking for signs of life, even fossilized life inside rocks that travel between planets. And now look at 3I Atlas. It is an interstellar Murchison. It is a messenger from another star system, actively releasing complex organic chemistry into our own. This implies that the ingredients for life are not a local phenomenon. They are not unique to our sun. They are galactic. The universe, it seems, is a vast, interconnected ecosystem, constantly exchanging these prebiotic seeds between star systems. The very compounds that led to us right here are likely common across the galaxy. This object isn't just a rock. It's a piece of our own cosmic ancestry, a long-lost relative we never knew we had. And this is the tragedy. The observation window is closing. 3I Atlas is now on its way. It's moving away from the sun at 31 kilometers per second, fast enough to escape our solar system's gravity forever. Every day it gets fainter. Every day we lose resolution. We have this one brief, precious moment to read the message in this 4.6+ billion-year-old bottle. The data we are gathering right now in these final days will be analyzed for years. Doctoral theses will be written. Models will be refined. But the raw observations, the photons hitting our detectors from this ancient traveler, those are happening now, and soon they will stop. We are losing it. This is why this event has lit a fire under the World Space Agencies. We record flat-footed. We saw Oumuamua and Atlas as they were leaving. We need to be ready for the next one. And that's where the ESA Comet Interceptor mission comes in. This is a real mission launching in the late 2020s. The concept is revolutionary. It's a probe that will be parked in a stable orbit at the L2 Lagrange point, where it will simply it will wait dormant for years if it has to. The moment next-generation observatories like the Vera Rubin Observatory spot a new interstellar visitor, the interceptor will get its signal. It will divert, fire its engines, and fly to meet it. And this isn't just a simple flyby. The Comet Interceptor is actually 3 spacecraft in one. The main craft will stay at a distance, observing the big picture while 2 smaller subprobes detach and fly through the comet's coma. One probe will be designed to analyze the gas and plasma, while the other maps the nucleus and dust. This will give us a 3D multi-point analysis of a pristine object, reading its chemical story from the inside out. We will, for the first time, open one of these time capsules and read its contents directly. And they are not alone. China's Zhenghe mission, also planned for this decade, is one of the most ambitious missions ever conceived. Its primary goal is to sample a near-Earth asteroid, but it has a secondary, groundbreaking objective: to deploy a nanoprobe that will attempt to intercept an interstellar object. The race is on. The first nation to successfully touch and analyze a pristine interstellar comet will unlock a new chapter in human history. They will be the first to read the mail from another star. That is the future. But for now, we are left with the fading light of 3I Atlas. We are the first generation of humans to know, for a fact, that our solar system is not an isolated island. The space between the stars is not an empty void. It is a cosmic highway, a network where material, chemistry, and perhaps even the seeds of life itself are constantly moving between systems. 3I Atlas has drifted beyond Mars, a frozen fragment from a star. We cannot name leaking water where physics says it should, carrying the chemical building blocks of life. What we have learned in these few short months will inform planetary science for decades. It adds a crucial chapter to our growing catalog of visitors from beyond. It forces us to ask if the ingredients for life are everywhere, just how common is life itself. When the next one arrives, and the Vera Rubin Observatory will likely find dozens, we need to be ready. We need to remember this moment. Remember the impossible water. Remember the alien chemistry. Remember that the universe is not a static, dead place, but a dynamic, evolving, and interconnected system. 3I Atlas was the universe whispering to us, the next one might be a shell. We just need to be ready to listen.